Alright, so let's go over the first do now from week 2. So, number 6 says, the light curve labeled C corresponds to the position in figure 1 labeled. Now here, I see that the magnitude is really, really low. So that means that one star has to be in front of the other here, which means that this is going to be position 3. It's going to be directly in front of the observer, and that's where the dip is going to go because it's completely eclipsing the other system. Alright, number 7. The period of revolution for eclipsing binary Q is about, and all I have to do for this one, it's actually really simple. This graph starts at 0 days and ends at 20 days. So the period is 20 days long. Alright, number 8. The stars in eclipsing binary Q alternately eclipse each other for periods of approximately. So here I go into the passage where it says a binary star system consists of 2 stars that are gravitationally bound to each other. If the stars that orbit are viewed along a line of sight, blah, 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 astronomers deduce that a given star is eclipsing from its light curve. It has a deep primary minimum and a shallower secondary minimum. So those are going to be where it's decreasing. Here, it starts decreasing here at 8 days and is at its lowest point at 10. So that's a period of 2. Here, it starts decreasing at 16 days, and it actually decreases all the way here to about 4 days until it gets to point B. So you go from the decrease through position A and to point B, 0 to 4, 16 to 20, that's 8 days. So the answer is H. Alright, number 9. The light curves for 2 eclipsing binaries, systems X and Z, are shown. Which of the following hypotheses would account for the deeper primary minimum of system Z? So, this introduces 2 new light graphs, and we want to know why this is lower than here. So, the reason that Q had a deep primary was that one star was brighter than the other, if you look back in the passage on the first page here. So the answer for this question is actually B. There is a more extreme difference between the magnitudes of the 2 stars of system Z than between the 2 stars of system X. So that means when the second star eclipses the brighter star, it's going to get way darker because the difference in how bright each star was is so different. Alright, number 10. The greatest total brightness shown on a light curve corresponds to the point in orbit when. And here would be actually where you're looking at this graph again. Here, if we're in position 3 and only 1 star is visible, you're only getting the brightness from 1 star. Same with position 1. So when 1 star is blocking the other, you won't get the brightness. But here, if we look at this star 2 right where it here, and this is the observer, you'd add the brightness of this star and the brightness of this star. So the answer is actually when both stars are visible, because no star is blocking another's brightness.